Welcome. My name's Aaron Wittrig. Welcome to my Zoom session. This talk is about CAS-ILE. It's a fully interactive code-based learning system. We use it for math, but it could be used for anything from theoretical physics to statistics. The idea of this sort of evolved out of the Calculus and Mathematica sequence at the University of Illinois. So I'm actually old enough to witness that myself. But yeah, that was one of the seminal programs of this kind, like where you had kids learning mathematics through code. So that eventually evolved into this online system. Up until this year, we used just 12 on-site servers that were hosted by the College of LAS, but they started complaining because it was an ancient operating system running ancient software, running like serving Mathematica 8. The queue system would always seize up and shut down. It was becoming untenable. So my idea was to do this instead through the cloud. So I'm going to do a brief demonstration of our technology, and then I'll sort of show you, however many people are here, how it works, what it is under the hood, and then I'll leave some time for questions in case there are any. Okay, so this is the development version. There's a new feature I'm about to release, which makes the calculations faster. So I'm on that. But at any given time, there are maybe 150 students banging away at the actual system, which is hosted at courseware.illinois.edu. Anyway, so let's get started. So this is the simplest sort of thing. 1 + 1. It came back correctly. And here, let's just look under the hood really quick at what this returns. So this called off to this server here, this application server, and sorry, I should have had this up. Oh, I hope they didn't do maintenance on here. No, they didn't. Okay, so sorry. All right, so this is the application server API. It's a bit complicated. I'm not going to go into this, but the important part of this is that it goes off to a Wolfram Cloud object, eval expression, and I'll show you what this returns. Oh, here we go. And so, okay, we've got the input here, and then it comes out as tech, and then we use comes back to the JavaScript. We use a tech to HTML converter to convert it to this pretty HTML here. So then also you'll see an empty symbols list here. So we needed some way to keep track of the symbols that were being defined. So basically, I'm just passing them all back and forth between the cloud and the application server, and here the client, and then to you, the viewer. And so here's well, let's start with n equals 1. So that returns 1. Then we can use, so as you can see, like we got name and definition n equals 1, and this includes everything you can imagine: own values, up values, down values, even options and attributes, and it's all encoded into a string. This is a very simple definition for purposes of this demonstration, and then it lists the dependencies, though that's maybe for the future, in case I decide to call the list down so that we're not passing back and forth every single thing. So, okay, we can use this result to do something else. This has full graphics. So yeah, plot x to the n, and then if I change n equals 2, the system keeps track of that. And so yeah, then we've got so then here we've got something a little more complicated. Let's do a 3D plot here. Oh, actually, the reason why that returned suspiciously fast, and the reason why is because I'm about to deploy a caching system, and the caching system lives on our application database, and it contains all the information that is returned here, and then also a hash of the input, hash of the output, and a list of the input variables, which is also fed to the API. So yeah, that's why it returns so fast. If we want to manipulate this, we can double click, and it returns that's another API which returns a web CDF to my client here. So as you can see, I can smoothly manipulate this here. We also have full dynamics integration. We can do manipulate. This is what we were doing before, except a manipulate version. Let's see if I can find what it returned originally here. Oh Christ! Here we go. So, so what this did is return a input form of it. That doesn't matter. What matters is this this attribute called ciphertext, which is obviously an enciphered version of not only the command to do this manipulate, but also all of its dependencies are encoded into here, so that if I save this and then come back to it later, I can still click this, or sorry, if I save this and leave this going, and the obviously the client is keeping track of the whole session here. So it'll forget the session when I come back, but it will remember how this manipulate was made so that it can make it again. And it's not extremely smooth. It's not client side, obviously. It's going back and forth all the way to the cloud. But it's bypassing my application server. So yeah, maybe I'll just go ahead and show some actual examples. So this is what this is the kind of thing that the student would be dealing with, and then this is actually some pretty good courseware. And here I'll do one more. So the student can do their own. The student can do their own version of, or the student can write code within the actual notebook itself. In fact, that's sort of the point of their homework. I thought some of these would be more impressive, but it's just a bunch of plots of points because it's just teaching them the basics. And sort of the beauty of this is that the students learn to code as they learn math. We've got an entire calculus sequence, like calculus 1 and 2, and then this is our vector calculus course. Oh wow, this is a lot. I think this is the last one. Oh, that's okay. And so yeah, this serves mostly high school students who are obviously advanced. So we've got the calculus sequence, we've got linear algebra, pre-calculus, probability and statistics course. So yeah, pretty much a whole suite of courses. They're designed lovingly by Jerry Ewell. He's dead now, but he was an amazing professor. And this was sort of his dream. Let me show you, we're gonna look under the hood real quick. All right, where are we? Okay, let's go to, all right, so I'm gonna show you first the very first version of this that I did. This is the, oh wait, no, I don't have this because this is the new, one. Yeah, I don't even have an old version of this, so we'll just go right in. I'm not really allowed to publish this, but I suppose if you took a couple screenshots, you would see what's going on. So this reads in 2 string inputs. There's the input here, which I'll give you guys an example of. Well, here we go. This is a perfect example here. So we've got the input stringified, and it can be, let's see. So it can be a bunch of inputs, and then what it does is, let's see if I've got a good example here. Let's get rid of these old ones. Sorry. Okay, let's see what we've got. I think I have a string version right. Okay, here we go. So let's just go ahead and do this. Sorry, my computer's from 2015. I love it. It was a really nice one when I got it, but yeah, I haven't been able to let it go. Here's Explorer. Okay, so let's just show how it converts this. So, so if we have a multiple input then this just returns to us a bunch of expressions that are in held form. Then there's a bunch of complicated stuff down here. Let's see. Here's what actually. Let's see. Okay. No, never mind. I won't go into super detail about that, but basically it feeds it unevaluated one by one to this part, which depending on whether it's graphics dynamic content or just textual content, it does different things. Like I said, it evaluates them one by one. With text content, it returns some tech, which, like I said, gets interpreted by the JavaScript. With graphics, depending on whether it's 2D or 3D, it either returns like or it returns just a big description of a PNG. And we can see this back over here. Here, let's do a new one. Okay. So yeah, we've got this image data, width, height, and source, which is just a description of a PNG, which it can interpret. Oh, and there's one other API, like in case somebody has to write math during the assignments, which they do. Let's just do something simple. One. Then that returns also as tech, which gets nestled right in here with the other text. Let's see. So then the manipulates were kind of a challenge because they let's see. So they return. Oops, I'm losing it. So yeah, well, like I described, they return as an encoded form of everything we need for the manipulate, and then that gets refed back into the application server, which and that's the client side of the application server. And so the JavaScript itself calls the other API, which is down here. Let's see. Not quite that much down there. Oh, here we go. Oh, display dynamics. So then basically that just decrypts it and returns a cloud CDF element, and those work pretty nicely. So yeah, I just thought it might be worthwhile to some people to hear about how we can base an entire course's evaluations and Mathematica formatting and all that on the Wolfram Cloud, and it works pretty well. And with the new caching system, it will also be pretty cheap. Right now, we're spending about $20 a day on it, but I'm about to install the caching system. And a lot of these evaluations, as you can probably imagine, since most of them are already written in the course, most of these are done again and again and again, and that's the main part of the cost for us. So we anticipate, based on data we've taken, that after this is in swing and has been allowed to cache some stuff, it'll go down at least an order of magnitude, maybe two. Well, let's not be too optimistic. Probably one order of magnitude, maybe $2 a day, which is quite reasonable. So yeah, that's pretty much what I wanted to expose here. Are there any questions? Oh, all right. A comment. My 14-year-old grandson loves math, especially baseball statistics. He will be headed to high school next year. This would be a great learning tool. Yeah, we take both independent and partner high school students. In other words, we partner up with high schools so that they can run this as a class themselves, and they. Mostly Illinois high schools, but they tend to really enjoy this interactive style of learning. The teachers are great. They do our grading for us. Actually, like, another thing I'm working on is an automated grader for this, and that's pretty challenging. But I'm working with an ECE professor here, who he's gonna like, he has a whole research group on this, because we have, as you can imagine, we have a huge amount of data that has piled up over the years of student submissions and teachers grading. So you can probably imagine that really lends itself to fine-tuning a large language model. So here we've got another comment or question. Hello, Director of Cloud at Wolfram here. I took original calculus and Mathematica via NetMath in high school, and was a NetMath. Oh, cool. NetMath mentor for 4 years in college. Great to see things continuing. I and my team would like to reach out more directly to see how you're using this and discuss more details. Absolutely. I would love that. Let me write down my email. So if anyone has any questions or wants to meet with me, or partner with NetMath or whatever, please reach out. We're always happy to talk. And yeah, unless there's any other questions or anything, I guess we can stop this here. But yeah, please reach out if you've got any other things you want to talk about. And thanks a lot, Gay. Yeah, that's about it. Thanks so much.